Betelgeuse, also known as a red giant star, would reach the orbit of Jupiter if placed where the Sun is. It is huge and very unstable, about to explode. Renowned scientist Brian Cox issued a very serious warning that begs the question: are we witnessing a supernova explosion that will change the night sky forever? In the vastness of the universe, stars are born, live, and die in a wonderful way. One star has recently attracted the attention and concern of astronomers and the general public. Betelgeuse, a red supergiant star in the constellation Orion. It is incredibly massive and ancient, and its unique reddish color and changing luster have long fascinated. Recent events have increased interest in this cosmic giant, indicating that we may be on the verge of a monumental event in its history. What could these Betelgeuse changes mean? Are we witnessing the beginning of an unimaginably grand cosmic spectacle? Betelgeuse is a giant star, approximately 764 times the size of our Sun. Its magnitude is almost beyond the human mind. If it were to replace our Sun, its surface would extend beyond the orbit of Mars and encompass Mercury, Venus, Earth, and Mars. This enormous size not only describes Betelgeuse's physical magnificence, but also indicates its stage in the star's life cycle. As a red supergiant, Betelgeuse is nearing the end of its life, expanding and cooling as its core runs out of hydrogen and fuses with helium. The age of the star is estimated to be 8 to 8.5 million years. Although relatively young in human terms, he is very old in star terms. Over millions of years, Betelgeuse underwent dramatic changes, evolving from a hot blue star to the red giant we see today. It is now in its final stages as a red supergiant, changing throughout its lifetime due to constant nuclear fusion and gravitational pressure. Betelgeuse's unique reddish color is due to its cooler surface temperature compared to other stars such as our Sun. The surface of the Sun is approximately 5,500 Kelvin, while the surface of Betelgeuse is approximately 3,500 Kelvin. Thanks to this cooler temperature, Betelgeuse emits light at wavelengths that make it appear red, revealing information about the physical state of the star and the processes taking place within its vast gaseous dimension. Historical records from the Roman and Chinese era indicate that Betelgeuse was yellow about 2,000 years ago. Since the 8th century, Arab astronomers noticed its red color, which represented the evolution of the star over time. Another fascinating aspect of Betelgeuse is its variable brightness. As a semi-periodic variable star, its brightness fluctuates from time to time, which has fascinated scientists and stargazers for centuries. Betelgeuse typically goes through a 400-day cycle and a longer 5-year cycle. Sir John Herschel documented these cycles as early as 1836, and indigenous folk history can go back even further. But what really makes Betelgeuse mysterious is not only its changes in brightness, but their irregularity. Unlike many stars that fluctuate in brightness in a predictable manner, Betelgeuse sometimes deviates from that pattern, suggesting complex and less understood processes in its massive form. Recently, astronomers around the world were shocked to see a dramatic and unexpected change in the appearance of Betelgeuse, known as the Big Dim. In late 2019, Betelgeuse began to mysteriously dim and rapidly lose its light. In February 2020, it was darkest. Betelgeuse, normally visible to the naked eye even in areas with significant light pollution, became much darker. This unprecedented decline has raised many questions and concerns. Observing Betelgeuse's activity is complicated by a time paradox. Betelgeuse's light takes almost 700 years to reach us, since it is about 725 light-years away. This time lag makes it difficult to predict and monitor rapid changes in this behavior. The event of the Great Darkening highlighted the difficulties of observing the heavens in real time and our limited understanding of their vast and mysterious dimensions of space and time. Andrea Dupree, Associate Director of the Harvard-Smithsonian Center for Astrophysics, and her team closely followed Betelgeuse's celestial drama. They used the Hubble Space Telescope to observe the massive star as part of a 3-year study to track changes in its outer atmosphere. These observations provided new insights into the workings of a variable star like Betelgeuse. The researchers studied the layers above Betelgeuse's surface, which, thanks to Hubble's sensitivity to ultraviolet light, were partially heated by the star's rotating convection elements. Further analysis of Hubble spectra taken at different times in 2019 and 2020 revealed the speeds of motion in the upper layers of Betelgeuse's atmosphere. The studies showed that material was moving from Betelgeuse's surface into the atmosphere at about 200,000 miles per hour. This hot, dense material eventually formed a cloud of dust that darkened the star during its 3-month explosion. Dupree and his team estimate that the southern hemisphere of Betelgeuse ejected approximately twice as much material as usual. Although all stars lose mass over time, Betelgeuse's mass loss was particularly significant because it occurred much faster than the Sun. Astronomers debated whether this event could be a sign of an imminent supernova explosion, given the size of the mass ejection and the decline that followed. Since Betelgeuse is only about 725 light-years from Earth, this adds to the intrigue, as any such explosion would be visible from Earth and provide a rare opportunity to observe a supernova up close. But the question remains, what does this dimming mean for the future of Betelgeuse? Is this a sign of an impending supernova or just a one-time event in the star's long and complicated life? Several theories have been proposed to explain this rapid change. One popular theory suggested that it was a precursor to the supernova explosion process, which gained traction because Betelgeuse was thought to be at the end of its life. Another common theory suggested that dust, perhaps from the star itself, is blocking our view. Betelgeuse and other red supergiants can eject material that can accumulate into a dust cloud thick enough to obscure the star's light. A third theory looked at how changes in a star's photosphere, or visible outer layer, could affect its apparent brightness. Spectroscopic studies have shown that Betelgeuse's effective temperature has decreased, suggesting that the star may be darkening due to a large dark spot on its surface. This idea was supported by the fact that the temperature of Betelgeuse decreased by at least 170 Kelvin during the eclipse. Finally, the Hubble Space Telescope helped us understand what happened to this unusual event. Hubble's observations indicated that the darkening of Betelgeuse was probably caused by the ejection of a large amount of hot matter into space, forming a dust cloud that covered part of the star's surface. This dust cloud was thought to consist of very hot plasma that erupted from a large convection cell on the star's surface. As that plasma moved through Betelgeuse's hot atmosphere into the cooler outer layers, it formed dust grains that created a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet spectroscopic studies, which began in January 2019, were crucial in piecing together the events that led to Betelgeuse's dimming. Those studies identified dense, hot material moving through the star's atmosphere in the months before the dimming. Several ground-based telescopes also observed a decrease in the star's brightness in December 2019, especially on its southern side. At first, the ejected material was brighter than the star itself, but as it moved outward and cooled,
it became a dark cloud. This outflowing material and the resulting dark cloud was thought to be the cause of the sudden dimming of the star. The explosion was huge and put Betelgeuse in the astronomical spotlight. The star ejected approximately 400 billion times the mass ejected from the normal coronal mass. This material, estimated to be many times the mass of the Moon, was important to both Betelgeuse and our understanding of stellar processes. What does such a massive ejection mean for Betelgeuse and supernova theories in general? This has profound consequences. Red supergiants like Betelgeuse are thought to lose mass fairly steadily before exploding at the end of their lives. But the extent of this separation calls this idea into question, suggesting a more turbulent and perhaps unpredictable final phase for these stars. Could Betelgeuse be preparing for its grand finale, a supernova explosion, in a few thousand years? New research suggests that such an event could occur sooner than previously thought, perhaps within just a few decades. Another important aspect of the Betelgeuse puzzle is the spring shock concept. This massive star is hurtling through space relative to the surrounding interstellar material at a speed of about 67,000 miles per hour, creating a bow shock similar to the wave produced by the bow of a ship moving on water. This effect occurs when the outer layers of the star interact with interstellar gas and dust. This is a vivid example of how dynamic a star is and how it interacts with its environment. The bow shock not only shows Betelgeuse's current position, but also provides insight into stellar evolution and mass loss. What about the star's recent behavior? Observations show that Betelgeuse's surface cooled and became less dense after the material poured out, suggesting that the star remains unstable years later. Hydrodynamic models combine the convective functions of the star, the removal of mass, and the subsequent change of the pulsation state. This continued instability raises questions about the internal processes at play and how they might culminate in a possible supernova explosion of the star. Understanding these processes is important for predicting when and how Betelgeuse might explode. Scientists are constantly monitoring these activities, looking for clues as to what might happen next. Could Betelgeuse explode soon? Experts say it is not immediate, but it is expected to happen within the next 100,000 years. A supernova is a remarkable cosmic event that can be seen from Earth even during the day and produces as much light as a full moon. The exact time is uncertain, but continued observations and research will improve our understanding of Betelgeuse and help predict when this remarkable event might occur. The recent dramatic changes in Betelgeuse offer an exciting opportunity to learn more about the processes that lead to supernova explosions. Scientists are particularly interested in understanding the internal mechanisms that cause such mass ejections and how they affect the evolution of the star. This information will not only improve our understanding of Betelgeuse, but also contribute to the broader field of stellar astrophysics. Continued monitoring of Betelgeuse and advanced modeling provide valuable information that scientists can use to refine predictions about the star's future. As new technologies and observational techniques develop, we gain a deeper understanding of the life cycle of stars and the phenomena that shape our universe. In conclusion, Betelgeuse is a fascinating and enigmatic star on the verge of an extraordinary transformation. Recent dramatic changes in its brightness and mass ejection have fascinated the scientific community and the public, highlighting the star's unique properties and complex processes in its evolution. Although the exact time of this supernova explosion remains uncertain, ongoing research and observations are shedding light on the mysteries of this stellar giant and bringing us closer to witnessing a cosmic spectacle of unprecedented magnitude.